we are going to use a package called SocialMediaLab. If you have not installed this, you'll have to go to packages and click install. And there you can find SocialMediaLab. So next we need Google Developer API key. So for this one, you need to have a Google account. Let's do this for YouTube. So let's go to Developer Console. So if you have already enabled APIs, so your API is going to appear below credentials. So that API key will have a creation date and then the key you can get here. So this is what we are going to copy and paste into RStudio. So we'll store this key in API key. So I'm going to put XXX here, but you need to copy and paste your API key and then run this line. We can use authenticate with YouTube API, where we can mention this API key, and let's store this in key. So now we can collect data. So I'm going to put some video IDs and store them in video. Let's go to YouTube. So suppose I want a video involving cluster analysis with R. So I'm just going to type cluster R. And let's go with this one, introduction to cluster analysis with R. So this is the ID in that link. So we can copy this and paste it here. And let me put this in quotes. And I'll get rid of this. We don't need the entire link. Let's get one more video ID. Random forest R. So let's get this one here. Copy link. So in this link, video ID is this one. So now I'm going to get rid of this. So we have these video IDs for 2 YouTube videos. So next we use collect data YouTube. We can say that our video IDs are in this video. We have to specify our key that we created in line 6. We can also say write to file, false. And let's store this in YT data for YouTube data. So now we can run this. So you can see now it has completed run and the data is ready. If you want to look at the structure of the data, you can say str for structure, and our data is in YT data. So it has all these columns. There are 223 observations, so that many rows. So you have 9 different columns. Let's write this to a CSV file. So our data is in YT data. So I want to store this on desktop, and let's call this as YT for YouTube.csv. And we can also say row.names equals false. As soon as we run this, you'll notice that a file here has been created. It's called yt.csv. So we can say read.csv file.choose, and because columns have a title, I'm going to say header equals true, and we'll store this in simply data. So if you run this, you can go to desktop and you'll see the file is here, yt.csv, and we can simply read this. So if you look at the structure of the data, so we have the same thing that we had. So comment is a factor variable, user is also factor variable, so it's just a name. You can also click on data and it will show you glimpse of what the data set looks like. So you have usernames, reply count, and so on. And there's a column called reply to another user. If somebody has replied to a comment on YouTube, so there you can see who the user is. But if there is a comment which has no reply from anybody, so in this column that value will be false. So what I'm going to do is I want to extract only those rows where reply to another user column is not false, so that I can do some kind of user network analysis and see how much users are interacting with comments. So I will create another data. So within this data, I want to specify that data $ reply to another user. So this variable is not, for is not we use exclamation mark followed by equal sign and then false. So it is not false. So we want those rows, and then you put a comma. After comma we don't put anything because we want all columns. So if you run this, you may notice now initially there were 223 observations, but now we have only 123. So this is 123 because all the rows where reply to another user information was false now has been deleted. All the rows now have a username. From this data, let's create a data frame and store that in Y. So one column we want is data $user. So remember, second column is for user and U is capital. So we should use capital U. And the second column we want is data $reply to another user. So now Y has two columns. If you click on Y, you will see two columns. So one user to other user. So now we can create a user network. So for that we need a library, iGraph. So to create this network, we use graph.data.frame, and our data is in Y, and we want a directed graph. So we can say directed equals true. So if there is a comment from one user to another user, so A to B, then we want an arrow from A to B. We'll store this in net, short form for network. So let's simplify. So if a user replies to a comment by himself or herself, so we want to eliminate those links. So we run this. Now if you want to look at vertices, we can do vnet. So these are some of the vertices. So each vertex is a user. Similarly, we can also have a look at edges by using E and then net. So there are 90 vertices, so that means 90 users have interacted using a comment. And there are 89 edges, a comment from one user to other user, so that forms an edge. So let's say vnet and then $, so label we want to use vnet name. Similarly, vnet degree net. So degree is basically number of connections. So for example, if you want to run this, so this will give you number of connection for each user. So there are many users. In fact, most of the users have not commented more than once. And I want green color for the bars in the histogram, and the main title will be histogram of the node degree. Y label we want to be, so this will be simply frequency, and title of the x-axis is going to be degree of vertices. So let's have some room here. So in fact, there are only 2 bars, and most of the users have not made too many comments, so that's why frequency is less. So let's plot the network NET. So we want vertex size to be bigger if the degree is more and smaller if the degree is less. So let's say we vary this by the degree and multiply this by 0.2. So we can say 0.2 times vnet degree. So vertex size will change with the degree. So let's say we want edge arrow size to be 0.1. Vertex label size, so for that we use CEX. So let's vary this by the degree. So let's use the same thing, 0.2 times and then degree. So if we run this network diagram, it looks like this. The thing is, this is too big, so let me make this smaller. So let this be 0.01. Because these videos were created by me, so whenever there is a user comment, there may be just one comment and I may respond to that. So number of responses from me are very high. A user may not have gone beyond one comment. So that's why you see this node is quite big and other nodes are very, very small. So this is the network diagram based on the data we have. So next, let's do sentiment analysis of the comments. And we'll use a library called SYUZHET. So if you have not installed this package, you'll have to first install this. So let's first read the file. And we'll read this in data again. So our file name was yt.csv. So I'm just going to read that. And for sentiment analysis, we'll only use comments, which is in the first column. So let's store all the comments in comments using ICONV. So all the comments are now stored in comment. So next we obtain sentiment scores using get underscore nrc sentiment. So we can say we want comments, and we'll store this in S for score. So if you want to look at first few rows of S, you can do head S. So this is what we get. So we get various scores for different sentiments. And the last two columns are negative and positive. In fact, we can create one more column which will indicate how many comments are neutral. So for that, we can type if else S $ negative plus S $ positive. So if this number is 0, so for equal to, in R we use two equal to signs. So if this is 0, then 1, else this value will be 0. And we'll store this in S $ neutral. So now if you run head S, you will find that now there is a column for neutral also. So if you want to look at any specific comment, for example number 3, we can say comments and then 3. So you get some comment here. So let's make a bar plot. So what we'll do is we create a percentage by multiplying 100 and column sums. So each column is now added, and then we divide this by overall sum of S. And we can also indicate that we want the x-axis labels to be like vertical to accommodate everything. And because there are 10 columns, let's say we want rainbow with 10 colors, and Y label percentage. So main title is sentiment scores for YouTube comments. So let's run this. So it gives a bar plot of sentiment scores for YouTube comments from those two videos that we pulled data from. And you can see comments are mostly positive. That's the highest bar, followed by neutral. So there are many comments which are more or less neutral. And also there is a small bar for negative. Trust, that bar also is quite high. Joy is quite high, and anticipation is quite high. So overall sentiment is quite positive for those two videos. So this approach can also be used for comparing maybe two different types of videos and checking what the sentiments are.